Everybody out there in Panther country, it's Tim Whitaker coming to you with Panther Vodcast number 9, and my guest today is high school tech ed teacher Garret Wenzel. Welcome, Garret.
Hi, thanks for having me.
You bet. Let's start out with the easy one. Tell us a little bit about yourself and your background.
Well, this is my sixth year here at St. Croix Central High School, and 10th year teaching overall. Prior to this, I taught south of Madison, middle school tech ed down in Milton Middle School. As far as my background, I have a degree in technology education, master's in education. In the summer, I end up picking up a lot of side jobs as far as, doing cabinet making and things like that related to what I teach. So I guess that's kind of me in a nutshell.
Where'd you get your bachelor's degree and your master's degree from?
Bachelor's and master's were both from UW-Stout. UW-Stout's really one of the only four-year colleges that actually offers tech ed as a degree.
Yep. Well known for that in the Midwest. All right. So what about family? Tell us a little bit about your family, Garret.
Well, it's just me and my wife and our two dogs. No kids yet. We ended up just end of last school year sold our house and kind of bought a new house, which is a little bit of a project. So going through some renovations and things like that, and then we'll probably kind of get a jump start on a family after that and have some kids and everything. So that's, I guess, kind of the plan.
Who's the contract on your house?
You're looking at them.
Yeah. What kind of dogs?
We have a pug and a Boston Terrier.
Okay. All right. So why did you choose a career in technical education?
Really for me, it was in high school. I loved shop classes. Really, it was the woodworking classes that I liked. Growing up, my dad is a contractor, so we do a lot of projects on the side as well at home. So I've always kind of had a good, connection to the trades and everything. And I thought of going into that as a career. But for whatever reason, I had a really good shop teacher in high school, and I just kind of felt, hey, this looks like kind of a cool job. And, my anticipation was going in and being a woodworking teacher, and obviously it's not quite just that. It's a lot more. So that's kind of what got me into it, and really it's just been an awesome career from there. I think that as far as, education goes for me, it's just awesome being able to learn new things all the time, working with kids and high school students and being able to share my knowledge with them. I try to keep up and learn new things every year. And obviously, and we'll get, talk about the Fab Lab and everything else in a little bit, but it's from where I anticipated of being a woodworking teacher to what I do now, totally different. I never thought I'd be taking on robotics and electricity and electronics and CAD stuff and metalworking and everything else. But it's awesome. It's all related. It's all hands-on, which is, kind of what I'm all about. And, having those being able to pass skills on to kids is just awesome.
So talk a little bit about your first year at SCC. What was that like?
Oh, well, let's see here. It was good. Obviously, I didn't come in as a brand new teacher, so I had a few years underneath my belt. But, it was just awesome coming into this I guess, high school. It really had a good atmosphere, very supportive, and really kind of felt like home pretty quickly here. And starting off here at, where our I guess where we kind of started and where we ended up right now, it's been quite a bit of change here. But I think for the better all the way around. But it's been a great experience as far as I can remember from my first year. I mean, it's always kind of crazy working with high school students and stuff like that. So it's a little bit of a learning experience. But the students that we have, we're awesome, and I think it's all working out pretty well.
So talk about that progression, what you had that first year of classes and equipment, and then kind of what was added and what changed, because obviously a lot has changed since then.
Yeah, we've really added a lot of new equipment. When I first came here, fairly traditional program, really focused on woodworking, metalworking. They did some CAD, but it was kind of just one of those classes that was just thrown into the mix, and it wasn't super popular or anything. So we've really, I guess, kind of flipped everything around. And, I guess when we really started this whole flipping around all of our classes and everything, it's just, where do we go to look and see what should we be doing? Obviously the trades are always huge, so woodworking and metalworking will never go away. That's an important aspect. But what I did is I went out to industry, and that's kind of one of the cool parts of my job is I get to tour a lot of factories and really try to get out there. I've spent the summer at 3M. I try to take field trips with the kids. We're in a huge manufacturing area, being so close to the cities that it's just amazing what they make out. Even in Hammond, Roberts, Baldwin, all these local areas, they're making some awesome things. So I started thinking and touring these factories, and it's just like, man, everything's automated, and it's all computer driven. It all bases on CAD, and at some point the kids really. It needs to have that trickle down that it has to get down to the high school, for kids to really start understanding what's going on in manufacturing. And it ended up being that, a lot of people had perception that manufacturing is kind of a dirty, kind of dangerous job. But if you really get out on these tours, it's amazing the facilities around here. So that's I kind of really did base it on industries, showing what they're doing, and I'm bringing it into our high school on a smaller scale. So we ended up kind of, throwing in a lot of 3D printers and laser cutters, vinyl cutters, around plasma cutter, CNC router. It's all stuff that, is really, it's normal out in industry. So, and I know it's new to us, but it's been really cool this year. With the students, they're just kind of getting their feet wet, and same thing with me. It's my first time really going through this whole, I guess, digital fabrication. It's quite a learning experience, and really, this first go around, we just want to make sure students are getting comfortable with this equipment, how to use it, and what it can really do. I mean, we're just scratching the surface on what this equipment can do. So I'm hoping as the years progress, we're going to really dive in to some really cool projects here. And hopefully, it's really showcased what our students are capable of. I don't know if we go through a tour here.
Yeah, I was just going to comment. I've been at WITC and seen some of the machining areas, or toured Nexen up in Webster, and yeah, you're right. Everything is related to computer, and those environments. Some of those environments are as clean as any hospital. I mean, it's amazing how clean it is. And the precision machines, I know some of the machines that they have in these plants are over $1 million. I mean, it's just crazy how technical it is. Like you said, there's a kind of a misconception or a stigma. Like you said, they're dirty jobs, and and they're not. And what I like you mentioned, we're just kind of touching the tip of the iceberg, maybe about what the equipment and machines that we have can do. But I think the viewers will see here after the tour the opportunities that we offer kids. So many different opportunities, from engineering to the trades. And again, I think, with technical education, the stigma was, whatever, metals, woods, or auto mechanics. And that's kind of what you did in shop. But it's obviously so much more now with the high-tech equipment, hence the name technical education. So yeah, now it might be a good time. As most folks know, part of the referendum and renovations and remodeling that took place over the summer, a lot of it involved the technical education area, STEM and Fab Labs. So maybe take us on a little bit of tour if you can grab your laptop and kind of walk around.
Don't bounce around too much here, but I'll take on a quick tour, and then I should probably touch on what is a Fab Lab. Again, it's a word that I guess it's kind of common in my classes now in vocabulary, but there's probably a lot of people that don't know what it is. So I'll take you on a quick tour, and then we'll kind of sit down and talk about that. I'm going to flip you around here. Hopefully this works. Oh yeah, that works. Can you still hear me?
Yep.
Okay. So really, you know, with our Fab Lab here, we kind of have, it's just a small digital fabrication area as far as, you know, all the equipment that we have. Sorry, it's kind of a mess in some areas.
So Fab doesn't stand for fabulous, huh? It stands for fabrication.
It could be fabulous. That's how some kids might. But we do have some. Here's our, I guess, our CNC wire bender right here. Basically, we can take different shapes. It'll automatically bend it into any kind of form or size. We can do some welding to put it all together here. So that's our CNC wire bender. It's a cool tool that the kids are just kind of getting used to. The real popular ones are the 3D printers. We end up having, we have 4 of them now. Try to get them kind of right in a row there. So we have 40 3D printers, and really it's anything that you design on the computer, we can pretty much print it on this, and I don't know if there's anything in this one. But yeah, we have our 3D printers. They're pretty cool as far as just being able to print off prototypes pretty quickly. You know, and the capabilities of these 3D printers, it still just amazes me of what they're able to actually do and make it seem so easy.
Do you have a couple of samples of things that students have printed out handy?
Trouble is, a lot of times they print them and then take them home. I mean,
okay, well, that's all right.
Kind of bouncing all over the place, but well, here I got one. All right, sorry, I'm just kind of holding it in front. But this is actually, and I'll set it down on a chair here. This is a U-joint that a student actually designed on CAD and kind of replicated. So, you know, it's one of those where you can actually rotate it around. It's, you know, a movable object, but, you know, it is all 3D printed, and, you know, all the parts go together easily, you know, very precise. So that's kind of a cool example of, I guess, one of the things that a student did 3D print here.
So on a 3D printer, is it always plastic?
Well, yes and no. For now, as far as we know, it is plastic, but I'm starting to see that there are some new different materials coming out. I know that there's one where it can be used in a 3D printer, and then you put it in kind of an oven afterwards, or even like a high temp furnace, and it has enough metal in it that will actually melt all the plastic away and then kind of bind all the metal together. So you're actually able to kind of 3D print metal in that way. There are some out there with, as far as with 3D printers, if you really look at the big, I guess, industry, they can 3D print metal. They have 3D printed a human liver before. I'm not really sure how they did that. You know, they've actually taken the DNA out of a rhinoceros horn, replicated the DNA, and then used 3D printers to make, you know, rhinoceros horns that have the same, you know, makeup, DNA makeup. And they did that to try to help reduce poaching on that animal.
Yeah, I saw that.
It's just crazy stuff what you can 3D print. I know, and then the fun ones out there are like chocolate 3D printers, so you can make a bunch of fancy, you know, chocolate that you can eat and stuff like that. So I think, you know, really 3D printing, it's a growth industry. They're really projecting that to continue to grow. It's going to be kind of a cool industry to see what really comes out of it. So I think just giving kids a basic understanding of how a 3D printer works and what they can do with it, it's just, you know, so invaluable right there.
They are kind of slow right now, right? Like that, just one of those U-joints would take approximately how much time to print?
Yeah, this one, so like our U-joints here, I think the blue pieces that we kind of see here, you know, they probably took a couple hours, 3 hours or so.
Yep.
Which seems slow, but at the same time, to be able to design something on the computer and print out a prototype in the same day, that's pretty fast, you know, from an industry perspective. So that's our 3D printers. We do have our CNC mills here. Now, we just have desktop mills. We mainly mill out styrofoam or pieces of wood. Again, sorry, I'm just kind of walking to try to find a student example. So we had a student kind of mill this part out. It's kind of a skull out of a piece of wood. So again, they design it all on CAD, and then they machine it out. CNC machine. Don't worry, got the CNC.
Yeah, right.
um, CNC machines have really been around since the 80s, so they are used a ton out in industry. And again, just getting students to know how a CNC mill works is pretty huge. I had one.
Maybe explain to viewers what CNC stands for.
CNC is computer numerically controlled. So again, it basically you create whatever design on a CAD software and then output it to a CNC machine.
And CAD stands for?
Computer aided drafting.
There you go. All right.
So,
just in case somebody doesn't know what it stands for out there.
Absolutely. So really with these, they're pretty cool. They're very precise. You know, they can machine stuff in a couple thousandths of an inch. I had one student last year, again, who really liked the CAD program. He really liked the CNC machining. We got him lined up with a job at Engineered Propulsion Systems in New Richmond. And what they're doing is they're prototyping a whole brand new airplane engine. It's not even in production yet.
Wow.
So we got him there basically at an aerospace company when he was in high school. And he's working with millions of dollars of equipment. You know, the company thought he did an awesome job. They've really invested in him. He graduated. I think they're really trying to help him out with school, and they're trying to keep him on for a long time here. So it's cool to see that, you know, this equipment, you know, it's really helping gain student interest, and then they are taking advantage of it and taking it out to industry, and some, you know, industry partners are really starting to see that.
That's awesome. What else you got in a fab lab?
All right, here's our very popular ones. We have the laser cutter. We do have two lasers. There's a smaller one and a larger one. As far as the lasers go, really we can pretty much cut out of any material except for metal. So we'll actually cut through, you know, wood and things like that. We can engrave on almost any materials. I'm just trying to find.
Yeah, you can make glassware, mugs.
Yeah, we can engrave glasses, things like that. And again, this is a pretty quick machine that, you know, we design it, it'll cut it right out, and you know, we're making.
Yeah, you can even put like photographs or burn it right into wood and stuff like that.
Can do photos right into wood. Honestly, these machines, they can do a lot. They're I think one of the most popular ones that we have here.
I think you can engrave baseball bats, leather baseball gloves, just about anything, right?
Yep, we've engraved footballs before. We can do mirrors, glass. We've done stone, like marble tiles. It'll engrave right into those. So it's really cool to see what we can do with that. We do cut a lot of cardboard. I'm just going to grab another student example here. So you can kind of see this one. It's basically a cardboard structure. It's a press fit structure. So the student kind of designs it all out on, again, the CAD software. And then we have some other software that actually slices this all up and kind of figures out how it's going to go together. And then we just set it on the laser, it cuts it all out, and the student has to assemble it.
I didn't realize that. I thought the laser basically, you know, burned stuff, and I didn't realize it actually cut.
Yep, it's still cut way through. We've cut, you know, a lot of paper and wood and things like that. Again, this is a tool that if you go around Hammond here, you know, go to Guy Metals or even over to Baldwin to OEM or Donaldson and Baldwin, they all have laser cutters on a huge scale. Now, their laser cutters cost millions of dollars, and they use them for cutting out metal pieces. But again, it's something that transfers right into industry. The students are, you know, using some equipment on a little bit smaller scale here, but all the skills that they're gaining, again, just transfer right on over. So it's pretty cool to see that connection.
Neat.
We do have our vinyl cutter. There's our vinyl cutter, and you can see right behind you, Tim, there, you can see that your wall quote that we did on the vinyl cutter.
Yeah, I was going to point that out. I just got that up this afternoon, so thank you. Yeah. Intelligence plus character, that is the true goal of education. Martin Luther King Jr. So yeah, I sent over I think four quotes to you guys. You got them cut out, and got two of them up so far. Figuring it out how to install it, obviously straight, and how to peel the tape back and all that. But no, it's wonderful. Thank you. It's outstanding.
Yeah, so that one's really cool for doing vinyl decals. We can make vinyl decals that, I think our vinyl will be can be used outside for up to 4 years. So it's a pretty durable vinyl that we use. And again, this is a really popular one that students get to design kind of their own decals and everything. We can actually use this to make, if we buy a different type of material, we can cut out pieces and then basically iron on logos to shirts and stuff like that. So again, this is a pretty versatile machine, really popular with the students, and it's cool to see what they design with that.
Did you guys do the tiger or the panther head for the band doors?
Yeah, we did. I had a student that got ahead in class, so I kind of gave him a little side project there. So it's always nice to be able to kind of pick up those side projects so kids can kind of keep on advancing their skills.
Yeah. So is that all the equipment in the fab lab?
We do have a CNC router and a CNC mill. I'm not going to go out there right now because I'm afraid I might lose my wireless signal.
Okay. All right.
So that's why. Here, I'll flip back around. But yeah, we do have other equipment, and really we did just get a small foundry as well. So we'll be able to start doing some metal casting here, and we got some other equipment kind of on our wish list yet, but it's going to take a little bit of time to get.
So you want to just talk about the CNC router and plasma cutter a little?
Yeah, the CNC router will actually, it's kind of one that's used a lot in cabinet making. It'll cut out giant pieces of wood. Our router is a 4x8 table, so we can fit a whole sheet of plywood on there and basically cut out any parts. One of the goals that we want to do with that is I'm talking to Mr. Cooley, our band director, and possibly starting some kind of guitar building class in the future where students can actually design their guitars on CAD. We use the CNC router to actually machine them out, and they'd be electric guitars. But it would be cool to do that kind of connection there. And I think I've mentioned it to a few students, and I think they'd love it if we could start something like that. But one thing at a time, I guess.
Right.
And then our CNC plasma cutter, again, it's very similar to the router. But it uses a plasma torch to cut out pieces of metal instead. So we do a lot of metal signs. For our curriculum coordinator, Dr. Webb there, we just made some nice antler plaques for his European deer mounts. So those turned out really well. But again, we're just starting to really see the capabilities of that machine and what we can do. And really, I think the biggest limiting factor, with all this equipment is your imagination. It's what do you really want to do? And I still get, it's our first year, so we're all just kind of learning as we go. But there's a lot of students that, trying to having them understand that, hey, come in here and make what you want. You're the one that's in charge. You're running the show here. My goal is to get you to learn how to use the equipment and feel comfortable with it. But as far as what you make, it's on you. And that's kind of a new class for us. It's called How to Make Almost Anything. That's it's just focuses on all the digital fabrication equipment in the shop. And like I said, our goal is to get the students comfortable with the equipment. But as far as what they make, they design whatever they want. And obviously they have budgets and stuff to worry about. But I think that's going to be a really cool class in the future. Go ahead.
That's the Fab Lab, and you talked about defining the Fab Lab. And then, obviously there's a lot of other things you do in technical education too, with the robotics club and other things. But yeah, go ahead, and if you want to finish up the Fab Lab, what it is, and then maybe branch into the other areas of technical education.
Now, the Fab Lab, this could be a whole long conversation, but basically it was started by MIT. A professor there, I believe, or is one of the people in charge, I forget, Neil Gershenfeld. Sorry if I'm butchering his name, but he came up with this whole idea of basically kind of digital fabrication, but on a small scale. A lot of this equipment has been around for a long time, but it's only been available to large industries that had, huge budgets to buy the machines. So he saw that, hey, there are companies making some smaller equipment, kind of almost that individual could purchase them. And, he formed basically what they called the Fab Lab, which stands for Fabrication Laboratory. The whole premise of the Fab Lab, though, isn't just necessarily to be able to make what you want. it's a whole network, and we're not part of the network yet, and that's what I'm working towards this year. But there's about, I'm guessing right now, I know last year was 400 and some Fab Labs worldwide. I think it's well over 500, I would assume by now. And the whole premise is to have interconnected Fab Labs. What we should be setting up here in the near future is having our Fab Lab wired in through some webcams and a TV that we can connect to any Fab Lab worldwide. That way we can share ideas across the globe. And the other cool thing is I can email all these part files, and as long as they have the same equipment or similar equipment, they can replicate whatever I'm making here. So it's,
and vice versa, right?
Yep. Absolutely. So it's what they're trying to do is, really trying to help some of the global problems. And actually, there's quite a few Fab Labs now out in Africa and some really rural areas that they honestly depend on it to make some of the equipment that they need to live. So I think it's really, I guess I hope that we can kind of develop that sense of global awareness and sharing of ideas and realizing that, yeah, we're just a small town here in Hammond and Roberts, but we are connected globally, and we can share ideas all over the world, and be able to connect to some just awesome people around the world. So I think it's that whole mindset and that idea that students, I think they're going to have to grow into and realize, wow, we got some amazing capabilities here.
Yep, in a global society too. That's a great point you make. And your passion, obviously, for what you do is pretty evident. I just need to say that.
This Fab Lab thing didn't happen overnight. So, I came up with this idea probably 4 or 5 years ago now. And again, looking to industry and then kind of looking online, what are other, schools doing? And, I saw this Fab Lab thing. I'm like, what the heck is that? So I started looking into it and watching some YouTube videos on it. And, it just kind of developed. And I think the equipment's awesome, but it's that whole global awareness and that global society that we're all interconnected is the real cool part.
The timing of the referendum was obviously good, too, in order to expand the facilities. But then the equipment, just the equipment alone, I know was $100,000 was at least the budget. I think you got more than that with all your grant writing you've done. But just in that Fab Lab there, is it about $100,000 worth of equipment?
Yeah, between all the equipment, we're probably pushing closer to 150.
Wow.
So, which sounds like a lot, but in the scheme of things of what you're able to do, what the students are learning, it's not too bad. So I think it's pretty cool what we're able to do. But yeah, it did take a lot of grant writing and things like that to really get it to this point. And I think it's going to be continuing to be a lot of grant writing, to really keep on maintaining equipment, updating equipment, and things like that.
How many grants have you written? I know just in 3.5 years I've been here, I know you've written a lot. Quite a few.
I don't know as far as how many, but yeah. And, that's one of those things that as, starting off teaching, I never thought I'd get into grant writing. I never, it's just one of those where I kept doing it and I was persistent. Yeah, I got rejected on a lot of applications, but then I started, figuring out what I was doing wrong. And, it kind of came around that, the pieces just kind of came together, and I started getting a few grants here and there, and it just kind of snowballed. So I think it's been fortunate that way too. And as
your biggest grant is like $15,000, right? Like I don't want people to think like, okay, he's got $150,000. He wrote 2 grants and that covered it. It's a lot of work for a lot of little grants.
It's a lot of work, that's for sure. I think, it was a little under $15,000 for our largest grant, and a lot of them are a couple $1,000s here, a couple $1,000s there. So it's not just we get one big pot of money. It's
right.
That takes a lot of time here. So that's been cool, but as the Fab Lab progresses, again, I kind of have my plan laid out as far as implementing at the high school here. But I think that this really needs to be a community lab here as well. So we'll have some opportunities here, more so for the community to get into the Fab Lab in the future. basically, in the past, we've kind of had, I'm here every day, almost every day after school for at least an hour or two, just kind of helping students if they come in, and that is kind of our community time. But, I think it doesn't work unless people go through a class and get some education on the equipment, because there is a little bit of a learning curve to I guess mainly the software. The equipment's actually fairly easy to use. So my goal here is I'm shooting for mid-December to have some kind of community education class or a class on the weekend that we can get some people signed up for, and at least start focusing on one piece of software and one machine, and kind of just run a few classes throughout the winter and kind of have a theme to these classes, so that way, people are kind of on the same page, can help each other out as well. But I think once we start getting community members in here, it's going to be pretty cool. And that's one of those things that I see with all this, and where it's, I guess, going as far as the Fab Lab, is we do have to get community involvement. Really, with all this stuff, it's kind of been, I'm the only tech ed teacher here in the district right now. It's kind of getting to the point where, hey, we do need a little support. We need to, ideally get some volunteers in here. If we get community members that have experience in engineering or metalworking, woodworking, anything like that, I think it would be awesome to really have those volunteers come in and really support our students. I think the students would really get a lot out of that.
Yeah, and as we kind of walk around and look at each piece of equipment. I mean, that's one thing to get the equipment, but each piece of equipment consumes materials. So that's the other thing, is to sustain things. You need vinyl for the vinyl cutter. You need wire for the wire bender. You need styrofoam or wood for the mills. You need plastic, for the 3D printers. I mean, you need sheets of plywood for the CNC router, and sheets of metal for the CNC plasma cutter. I mean, all those things, in order to be sustainable, obviously, cost money. Now, you talked about kind of the vision or the future of tech ed or STEM or Fab Lab. I know a shared vision we've kind of started talking about this fall here as a district is kind of revolves around three different areas. One is the Panther farm or agriculture. One is like Panther production with video and audio production, more with our scoreboards and auditorium. The other, that as it applies to technical education, is manufacturing or construction. Do you want to kind of talk about maybe the vision and where you see things going in that respect?
Yeah, sure. And I guess backing up, Fab Lab is just kind of one of the parts of what I do, and that kind of falls into our STEM and engineering area, where students are able to design items, prototype, start, proving some ideas that they have. But I also teach the woodworking, and I teach metalworking once in a while, but Mr. Emery in our ag department usually teaches that in the small engines. But as far as the woodworking, if we, start developing our construction program a little bit more, really, again, it stems from the industry. Every, contractor I talking to our superintendent from Myron Construction here, the trades are just hurting. Nobody's going into them. And they need some new people in there, because you can make a really good living in the trades. And coming from, a family where my dad was in the trades, I've seen what he's been able to do. Yeah, there are tough times, but, you always have to work through it. And it's just like any other job, that you're going to have those tough times that you have to get through. So we're really trying to develop a little bit of a stronger construction program here. I, again, feel that we need the community. It's going to be, having ties to a technical college, having industry support, giving our students the opportunity to essentially get out of high school and start getting out in the real world a little bit, through a tech school or a industry partner, and actually getting skills essentially on the job. Kind of thinking of more of an apprenticeship program, in that regards. But I think we have some things kind of very rough ideas as far as, what kind of different construction projects can we do here, and what other elements do students need as far as OSHA training or, getting certified in different areas that we can do through the high school. But I think it comes down to, they need to get out and get some skills and get out in the industry, get their feet wet a little bit. So that's kind of what we're thinking as far as the construction side of things. As far as manufacturing, I think really for that to progress, I had a good conversation with my students earlier today, in one of my How to Make Almost Anything classes. And I told them, here's my plans. We have a How to Make Almost Anything class right now. Next semester, I'm going to implement this How to Make Almost Anything class, and I call it Make It Move just because I'm not really creative with new class names. But really, right now they're learning how to use the equipment. In the Make It Move class, we're going to start bringing in elements as far as like energy and power transmission. We're going to look at pneumatics and hydraulics, and then we're going to be able to use the Fab Lab equipment and make different machines to do different, whatever task we need to do. And I think that's going to give students an even, more in-depth perspective on things. Just because I see a lot of mechanical knowledge kind of lacking. And that's one of those things that leads right into the trades or engineering or a lot of different STEM careers. So with our final level, I'm hoping to utilize the Fab Lab and run some kind of, student-run manufacturing business. Is what we're kind of looking at. And honestly, just talking to students, they threw out a couple other ideas and they thought, oh, that business one actually sounds kind of cool, and seeing what they could actually design and create. And they're already thinking about, okay, well, if we make stuff, where can we sell it? We could do the school store, or is there other places we can sell it? And what kind of things do we need? So they're already kind of got their minds of, thinking, and it's just, trying to get them engaged and excited to be here.
Yep, and prepared for, the next step and, the real world, as we say. Now, you mentioned that you have the lab open for about an hour every day for students, or you might be expanding that to community. So that's part of your role as a STEM coordinator. But another thing that you do, speaking of moving parts, is the robotics club. You want to speak about that for a little bit?
Yeah, the robotics team is actually in its third year. And again, that's been quite a learning process for me. By no means do I have any really experience with robotics, but I saw that some students had interest in that. And I figured, hey, why not start a team? So right now we're part of Bots IQ, which is a Wisconsin-based competition. And it's a battle bot style competition, kind of just like the one that they had on TV, I think, over the summer. Maybe it's still on, I'm not sure. But the students design the robot from the ground up. They have to use their CAD software to actually figure out how everything's going to go together. We actually, last week, we just started doing some prototyping for our robot. Here, I can show you a prototype. We'll take a walk again here. But here's, a student's prototype that they're starting to figure out what they're going to do and how their robot's going to start taking shape. So the cool thing is, they designed that all in the computer, and we can laser cut from that part file. But, we could also take that same part file and send it to the plasma cutter. So the next step is once they kind of prototype, they'll go ahead and start cutting out of metal. And then they weld it all together. They have to do all the electronics inside and figure out how that's going to go together and do all the soldering. So it's an awesome experience for the students that they're building a robot from the ground up. So there's a ton of learning that goes into it, a ton of problem solving skills that they're gaining. And, I think it's just been an awesome team that they're part of. And over the last 3 years, it has been slowly growing, which is really cool to see. So I'm just trying to, get more students involved in that, and, hopefully they get a lot out of it, I guess.
Where are those BattleBot competitions held at?
Well, for the first 2 years, they were held in the Twin Cities at Dunwoody College. And then this last year, we had competitions down in the Milwaukee area. As far as this year, I know we have one competition scheduled in Milwaukee. I'm trying to see if we can find competitions in the Twin Cities or something a little bit closer so we don't have to travel so far.
So the students that built up in the first year or two, and maybe they're still in school, they get to reuse those bots year after year?
The first year, We didn't because it got totally demolished in the competition. Part of the learning process. So we can reuse them as long as they undergo major modifications. So we can, and some students this third year, we dug out the robots from last year and said, hey, we can use these. If we want, we can modify them, or we can start over from the ground up. And the students kind of like that idea of going from the ground up again, because again, they learned their mistakes from the first robot and they keep on, changing and making improvements, and makes it, they make it better every year. So it's pretty cool to see how some of the students on the team have really developed into some leadership roles and are really helping out the other students that may have just joined this year.
Yeah, because there's a real strategy, right? Obviously, they do the research and figure out which bots have the most success, whether it's make offensive or defensive position. Is that kind of correct?
Yep, they do a lot of research and then kind of look at different BattleBot designs. There's a lot of constraints. We're in a 15-pound robot class, so we can't be over 15 pounds at all. And there's certain constraints on types of weapons. Obviously, no explosives or anything like that can be used, but they got to really watch out for that. But it's kind of cool to see what they can come up with.
Yeah. So. One thing was pretty neat to start the year. I think we were, second, third week of school. We were contacted by Governor Walker's office, and he came and did a tour because, he supports the Fab Lab and the Fab, I think it's specifically called Fab Lab Grant. Is that correct? Yes. That you wrote for and received?
Yes.
Are you ready? Are you writing for that again, Garrett?
I actually am not.
Okay.
Because really the Fab Lab grant focused on specific equipment for the Fab Lab. And honestly, our Fab Lab's starting to develop enough that we have all the essential equipment that's on the list for that grant. Doesn't mean that we won't add other equipment in the future. But as far as, that grant, it just didn't work out this year. So we're looking at other fun types of funding and just making sure that we kind of keep things going. And really with this being the first year of implementation with the students, I think that's where a lot of my focus is, as far as making sure that the students really are getting the skills that they need with this equipment.
Yep, as it should be. So you mentioned you may have some community education classes coming up. That's kind of in the near future. Is that correct?
Yep. I'm trying to narrow down some dates and then kind of have some time here to plan out a little bit of a curriculum. But I as of right now, my rough idea is to kind of focus on our 2D CAD software, so it's kind of the easier software to learn, and then we'll probably focus on the plasma cutter. I'm going to try to schedule it before the holidays here, because with the plasma cutter we can do a lot of cool signs, or I guess plaques and antler mounts for deer and things like that. There's a lot of different things we can do with it that end up making good gifts for the holidays, so I figure let's try to do it mid-December. Yeah. So I'm going to try to get something together. Hopefully on break here I'll get that all done and start getting word out, and then we'll shoot for about mid-December. I'm planning on a Saturday, probably afternoon, for that, and kind of open up shop and see who can make it, and we'll kind of go from there. So it should be a good experience for any community members that might be interested. I'm also hoping to get a couple students there to kind of act as my assistants, just so that they can kind of show off their skills as well. And I think it'd be a awesome kind of community project.
So if folks want to get in touch with you, how do they reach you?
Well, you can shoot me an email. Looking at our school website, you can see that if you go to the high school webpage and click on academic departments, you'll see my webpage there. Otherwise, just send me an email. If you search the website, it is the gwenzel@scc.k12.wi.us. I know it's a long one to remember, so I always just direct people to the website. But I'll hopefully get everything out, and I'm hoping to really send out a little invite to all the parents here and things like that. And I think it should be a pretty good turnout that I bet some students are going to be excited to be able to have their parents here to see what kind of cool equipment they're working on.
Yeah, definitely. And like I said before, your enthusiasm and passion for what you do is very evident, and I know that bleeds over to the kids. They see it, and the kids that take your classes certainly are fortunate, and our hopes obviously are to give them a leg up if they go, into any one of these fields, and even if not, is just a great learning experience, and especially for the hands-on learners. So thank you for what you do, Garret.
Oh yeah,
any final thoughts before we wrap it up?
Not really. It's just, again, it's always fun to be working here at SEC. It's just been an awesome district to work for. Very supportive community. I think I got some things in the works on the horizon here for our manufacturing and construction, and hopefully things fall into place. I think it's going to be some really cool opportunities for students and kind of better prepare them for their future careers.
Yep, great. So stay tuned, folks. We may be doing another vodcast as things progress, but if nothing else, we're definitely going to get the word out then on those things that are in the hopper. So thanks again, Garret. It's the day before break here, so I want to wish everyone a happy Thanksgiving, and if you view this after Thanksgiving, hope you had a great Thanksgiving. So take care. Best wishes.
All right, thank you.
Yep.